Good morning, everybody. Before we get started with today's lesson, I want to say that I've been noticing a lot of people who are taking notes on their own paper are copying down every single word and all the pictures and stuff. And so make sure you're being efficient and you are summarizing for yourself and you are just writing down the things you need to from the stuff that is pre-typed. You don't need to write down everything that is already typed up if you aren't able to print things. So just a reminder on that. Okay, so today's notes, we are talking about perimeter and area of similar figures. And so we're going to kind of look at these two rectangles I have here for this big idea for today. So we have a little red rectangle and then we have a larger blue rectangle. And it says for the two figures pictured, compare the following. So we're going to compare the similarity ratio, the ratio of the perimeters, and the ratio of the areas. All right, so let's go ahead and take a look at this. So remember our similarity ratio. Our similarity ratio is what number do I multiply by to get from one figure to the other of corresponding sides. So let's identify our corresponding sides. So our short sides are 2 and 2t, and then our longer sides are 3 and 3t. So my similarity ratio is going to be 2 to 2t. Well, let's actually go big to large. That way it's a little better. So we're going to go from blue to red or big to large. Okay, similarity ratio. We're going to go big, not big to large, big to small. Okay, so we're going to compare the big one to the small one. So the big one is 2t and the smaller one is t, which reduces to t. All right, so that was comparing the shorter sides. Okay, my corresponding sides there. And then if I compare the other set of corresponding sides, we would get 3t divided by 3, which also reduces to t when I cancel those 3's. So my similarity ratio for this one is t. Okay, the ratio of the perimeters. All right, so let's find the perimeter of the red rectangle. So the perimeter of the red rectangle is 2 plus 2 plus 3 plus 3. Okay, so perimeter is 2 plus 2 plus 3 plus 3, which gives me 4 plus 6, so I get 10. And the perimeter of the blue rectangle is 2t plus 2t plus 3t plus 3t. So that would be 10 t's. Okay, so if I compare my similarity ratio, once again, we're going to go big rectangle to small rectangle. So that is comparing the blue rectangle to the red rectangle. I'm going to get 10t divided by t, divided by 10, which is just t. Okay, so what I did here was I said, okay, I'm going to compare the perimeter of the blue rectangle on the numerator and then the perimeter of the orange rectangle or red rectangle on the denominator. All right, now the ratio of the areas. Okay, so the area of this red rectangle is 2 times 3 or 6 units squared. And the area of the blue rectangle is going to be 2t times 3t, which is going to be 6t squared. Okay, and that's units squared. And so if I compare my area of ratios, once again, we're going to go big compared to small. So I'm going to say I have 6t squared divided by 6, which just reduces to t squared. Okay, so now if I compare all of these, I see that my similarity ratio and my ratio of perimeters are equal. Okay, so these two are the same. And then when I look at my ratio of the areas, the ratio of the areas is the square of the similarity ratio. And so that's going to lead us to our first theorem. Our only theorem for today. So our theorem is the area of similar polygons, and it says if two polygons are similar with the lengths of the corresponding sides in the ratio of a to b, then the ratio of their areas is a squared to b squared. So if my similarity ratio, and so if I look at these, we know they're similar, right? So I only need one pair of corresponding sides. So my similarity ratio of polygon 1 to polygon 2 is going to be A over B. Or remember, you can also write it as A colon B. Both of them read A to B. And then the area of the ratios, once again, from polygon 1 to polygon 2 is going to be A squared over B squared, or A squared to B squared using a colon. Okay, I typically will use the fraction form. Okay, so that is our big idea for today. We have 3 examples, so if you want to go ahead and try the examples now on your own and then come back and see how you did. All right, our first example says, in the diagram, triangle ABC is similar to triangle DEF. Find the indicated ratio. Part 1, the ratio of red to blue of the perimeters, and part 2, the ratio of red to blue of the areas. Okay, so in our exploration, we found that the ratio of the perimeters is the same as the similarity ratio. So if I know that these are similar, and I know that corresponding sides are shown, I know I have 8 to 12, which reduces to 2 over 3. So my answer here is 2/3 for my ratio of perimeters. And then the ratio of the areas, well, our theorem says that if the similarity ratio is A to B, then the ratio of the areas is A squared over B squared. So this would be 2 squared over 3 squared, which is going to be 4 over 9. Okay, so all I did here was I took this, that's my similarity ratio, I squared the top and the bottom, and then I reduced. Well, I don't need to reduce, but if I had to, I would. Okay, part B. A large rectangle baking pan is 15 inches long and 10 inches wide. A smaller pan is similar to the large pan, and the area of the smaller pan is 96 inches. Find the width of the smaller pan. Okay, so let's see which one they called length and which one they called width. So a large regular baking pan is 15 inches long, so this is my length, and 10 inches wide, so this is my width. So I am looking for this length right here. Okay, so this shorter length of my smaller pan is what I'm looking for. All right, so let's figure out how we might do this. So our area here of my large pan is 15 times 10, so I have 150 square inches. Okay, so I know that, let's see here. If I figure out the area, I do have the area of the smaller pan. So this area is 96 square inches. So I can figure out if I have the ratio of areas, I can then figure out the similarity ratio. So that would be helpful. Okay, so let's start with that. So the area of smaller pan compared to the area of the larger pan is going to be 96 square inches over 150 square inches. So my ratio of areas is 16 over 25 when I reduce those. Okay, so now I know if I take the square root of those, I'm going to get my similarity ratio. Because my similarity ratio, when I square it, gives me the ratio of the areas. So my similarity ratio is going to be 4 to 5, because the square root of 16 is 4 and the square root of 25 is 5. So that can help me now with my side lengths. Okay, so I know my similarity ratio is 4/5. So when I compare corresponding sides, so my 10 and my x, so let's see here, am I going from small to big? Yep, I'm going from small to big. So small to big, small side is x, big side is 10. Okay, corresponding side on the small figure is x, corresponding side on the big figure is 10, and that needs to equal the same thing as 4/5. And we can see that I just multiply by 2 to get from 5 to 10, so x would equal 8 inches, or you can cross multiply if you want to. So you can cross multiply and say, okay, I get 5x equals 10 times 4, So I get 5x equals 40. Divide both sides by 5. And I get x equals 8. Okay, so my answer is 8 inches on that one. All right, so the big idea, what did we do? We knew the ratio of the areas. So we simplified that and we said, hey, the ratio of the areas is the square of the similarity ratio. So I took the square root of it to find my similarity ratio to then set up a proportion. Okay, next question. I believe your notes are missing the picture of the gazebo, but it is not important to the question for the next one. So just so you know. Okay. It says the floor of the gazebo shown is a regular octagon. All right. Each side of the floor is 8 feet and the area is about 309 square feet. You build a small model gazebo in the shape of a regular octagon. The perimeter of the floor model is 24 inches. Find the area of the floor of the model gazebo of the nearest tenth of a square inch. Okay, so here we go. So we have our real gazebo, which I am not good at drawing octagons. Okay, so this is my actual gazebo. And then we have our little model gazebo, which is smaller. All right, okay, let's see here. The floor of the gazebo shown is a regular octagon. Each side length is 8 feet. Okay, let's write that down, 8 feet. And the area is about 309 square feet. You build a small gazebo. Okay, the perimeter, so perimeter is 24 inches. Find the area. Okay, so let's think. How can we do this? So I have perimeter of the model, but not perimeter of the actual. I could easily figure out that. So let's remind ourselves. The word regular means that all of my side lengths are congruent. So all of these sides on this one are 8 feet. So my perimeter here is going to be 8 times 8. So my perimeter is going to be 64 inches here. All right, so my ratio of perimeters. So perimeter of model to perimeter of my actual gazebo is going to be 24 to 64, which reduces to, oh, look at this. I just made a mistake. I wrote down inches here, and it is not inches. It is feet. Uh-oh. Okay, let's erase that. Let's erase. This is in feet. So let's convert the other one to feet. So perimeter is 2 feet. 24 inches is 2 feet on my small model. So this is inches, and this is feet. So then I get 2 feet over 64 feet. Got to make sure our units are matching. So then I am going to have 1 over 32. So perimeter of the model to perimeter of the actual is 132. Okay, and remember the ratio of perimeters is the same as my similarity ratio. Okay, so then if I want the ratio of areas, I'm going to have 1 squared over 32 squared, which is 1,000, 1 over 1,024. Okay, so that's my ratio of areas from my model to my actual gazebo. So let's put it in. So if we have model area, which we don't know, okay, that's our X, model area, over my actual gazebo area, which we know is 309, that needs to be the same as 1 over 1,024. Okay, so if I replace model area with an X, I get 1,024x equals 1 times 309. And if I divide both sides by 300 or by 1,204, I'm going to get x is approximately 0.302. And my units here, let's see, what units did we switch to? We switched everything to feet. Okay, so this is going to be feet in my doing area, feet squared. All right. But, our model was measured in inches. So we should probably also give the area in inches. All right. So let's convert to inches. So let's think about this. So if I have 1 square foot, that is 12 inches by 12 inches, which is 144 inches squared. So 1 square foot is equivalent to 144 square inches. So I'm going to multiply this by 144 square inches, and I'm going to get that X is approximately 43.5 square inches. All right. Okay. This one was a little tricky because of all the conversions and stuff. So go ahead, try your homework, and let me know if you have any questions.